Hello everyone. My final year project is titled as DeFi Trust. It is a transformer-based framework for scam DeFi token detection using event logs and sentiment analysis. Now, you all probably heard about cryptocurrencies and blockchain technology. Smart contracts are essentially computer programs that runs on a blockchain platform. Now we'll see what is specifically a token smart contract is. A token is a form of authorization, such as cryptocurrency ownership. So the token values are defined by supply and demand, just like any other cryptocurrencies. And social media discussions affects the cryptocurrency market. But there's a catch. Although other cryptocurrencies such as Ethereum and Bitcoin are managed by the underlying blockchain itself, the token cryptocurrencies are managed by the token smart contracts. The smart contracts issues and manage the tokens, and anyone can create a token and provide it to the market. Therefore, there are many malicious and faulty tokens. So the problem this research tries to address is, given transaction data and social media data about a DeFi token, how to recognize if it is a scam as early as possible. Now, there are existing work in this domain, but there are some differences between those existing work and the proposed framework in this project. First of all, the existing works used token transaction data and pool data as the inputs. But in this research, I have used token transaction data and social media data about that token. Then existing works used a tabular set of features and tabular machine learning models. But in this research, I have used a sequence of features and sequence models. And the previous research were done to classify existing tokens that are listed on Uniswap exchange, but this research was done to classify a given token with only using the latest information. And this framework is to be used in different real-life situations about DeFi tokens. And this is the model architecture of the proposed framework. As you can see, it is comprised of two different branches. One, processing blockchain transaction data, and the other one, processing social media data. Using transform encoders, this model converts those two input streams into temporal embeddings and concatenate them to produce a binary output to state whether that token is a scam or trustworthy one. Now we'll see how this DeFi trust model stands against other machine learning models that are used by previous researchers. As you can see, it had the best accuracy, precision, and specificity metrics. And the recall matrix was not the best because the DeFi trust model misclassified some trustworthy tokens as scam. But it is acceptable in this domain because it very rarely misclassifies a scam token as a trustworthy token. That is the most dangerous thing. Then, to see how the integration of social media affect this research, I created another model using only the transaction data. What I did was, I removed the bottom branch of the DeFi trust model and trained this separate part as another model, and this is the results. As you can see, the integration of social media had improved accuracy, precision, and specificity metrics. Now we will see how we can use this framework in real life situations of DeFi tokens. Right, so this is the interface of the framework. You can go to Etherscan and select a token such as Chainlink, copy its address and paste it here. And you can take these explanations to get the machine learning explanations using diagrams. And just like that, the framework managed to extract the required blockchain transaction data and social media data in about a minute and produce the results. As expected, it It predicted as a trustworthy token because the Chainlink token is a very famous and widely used token. So we'll see how it will perform against tokens such as this one. It is a famous scam token. As expected, this spam token is identified as a scam. Now, the first diagram here represents how each of the features have affected the model decision. And here in the second diagram, it represents how the most significant feature, which is identified as the block difference feature, and its value when the integrated gradient variated throughout the time periods. And these two diagrams represents how the sentiment of the social media variated and the corresponding integrated gradient variated throughout the time steps. So as you saw, this framework can be used by investors and traders to gain another perspective before investing on DeFi tokens. I'm Manisha Gunatilaka, and this research was supervised by Dr. Sandrika Vikramanayaka and Dr. Dilum Bandara. And thank you for watching.